Good evening, Paul.
Good evening, sir.
Good evening, sir.
Good evening. Have I done slab design actually previously? Hello. स्लैब डिजाइन हुआ था क्या पहले? No, sir. Okay. We'll cover that today. Yesterday we have seen the detailing part, but I think design is pending. See, we are having Excel sheet for the slab design. One-way continuous, then two-way slab, and simply supported slab. Okay. So we can do the design by using this. So in the beginning, let's discuss. See, this S2 is one-way slab, and we can assume this as a simply supported also in this case. So we will design this S2 slab first. So what kind of load come on the slab? Let's say this is a S2 slab. So what kind of loads will come on that S2? Loads?
Dead load.
So dead load means it is a self weight. Self weight means it depends on the thickness of the slab. Then SIDL means superimposed dead load. What is that SIDL in this case? In S2?
Floor finish.
Sunk.
So it will be floor finish and sunk. So plus sunk we can say. So if we assume floor finish 0.05, that is 50 mm into density, we can consider floor finish maybe 22 something. And sunk is, it depends on the thickness of the sunk. Let's say thickness of the sunk is 0.3 meters into, we generally put the brick bat into that. So it will be 20. So how much is the SIDL in this case? Say roughly 1, and this will be 6. So 7, or it will be 1 point, I think 1, 7.1. You can assume 7.1, or you can assume this round up. Let's round it out. 8 kilonewton per square meter. Then if you have the thickness of the slab, then self weight we can calculate. Let's say thickness of the slab is 0.125. So the density will be, let's say 0.12. So it is 3 kilonewton per square meter. So these are the loads, and yes, we have the lie load also. So let's say lie load is on toilet, it is how much? So we are having 3 types of load. One is the dead load, self weight, lie load, and SIDL. So here we can put that values in this and the span also. So let's say we will consider the simply supported beam case in Excel program. Grade of concrete 20, grade of steel 500, and cover to the reinforcement, let's say it is a 20 mm. S2. Okay. Now span of the slab. What is the span of slab in our case? Here you can see 1.17 meters. You can assume center to center slab. Whenever you design, no need to say, we have seen that manually, but you can assume this center to center of this beam. Okay. In this case, it is 1.17 meters. So put the values here. 1. Thickness you can assume 120, let's say. High load is 2. And floor finish load, how much we are getting here? As finish means you need to add a sunk and all finish, whatever is there, which is 8. Now see, it is calculating the bending moment automatically. So total load is 19.5. So bending moment is 3.37. Automatically it is calculating, and it is asking where you want to put the reinforcement. So outermost reinforcement along which span? So definitely main steel is always along the short span. So we will click here as a short span. I think last time we discussed this in slabs, one-way slab. As this is your direction of the slab, then your main steel will also be in that direction, this one. So this main steel will be outermost, and there will be distribution which is horizontal, which is above the main steel. So if you see the section, last time also in drawing session we have discussed this. If you see this section A, then how will it look like? It will look like, let's say this is your beam and this is your slab, and this is your 1.17 meters, 1170 meters. So your main steel is this horizontal blue color, and you will have the distribution bars above that. So the dots are above this. And why we do this? Because we get more effective depth. So in the similar fashions, it is asking where you want to put the reinforcement. So we want along short span, main steel. Then you can assume the bar diameter, let's say assume 8 mm for short span, and even distribution also, let's say 8 mm. Now it will give automatically how much AST is required. So AST required is 144. So you can provide, let's say 150. How much is the steel coming? So this is your main steel along short span, and this is your distribution steel. So 8 at 285 and 8 at 285. Here you can see final status is okay. So that's the simple design actually. Simply supported beam is very easy to understand. Are you getting this?
Yes, sir.
Yes, all of you. समझ में आया क्या? बहुत ही आसान है ये.
Yes, sir.
Yes.
Then we have this. So there is a S6 also, which is 1.845, and it is a balcony slab. So in balcony we are having a sunk of 150 mm. So in the similar fashion, you will do that also. So we need not to calculate dead load actually. Let's say S6 dead load will be calculated by Excel automatically. Assume the thickness, let's say 120 mm. Then SIDL will be balcony is having sunk 0.15, that is 150 mm into 20, and floor finish same. It will be same. So the number will be 3 plus 4.1. If you don't want to round up, then you can take this value also, no problem. And lie load in balcony, how much?
3 kilonewton.
It
3
is 3
kilonewton.
per square meter, kilonewton per square meter. So you can put these values here then. Span is how much? Span is 1.845. Okay. Put this 1.845. Let's assume this lie load is 3. SIDL is 4.1. Same. Along short span, moment is coming out to be 6.446. Generally we start the reinforcement in slab from 8 mm nowadays. 6 mm is now not used. How much AST required? 161. Let's put 165. As the span is very less, you are getting the same steel actually here. So if the spans are more, then you will get more steel here. So let's go here. Let's assume this span is 3 meters. Okay. All other things are same. Let's say your cantilever balcony is having 3 meter span one way. So how much? So AST required is 464. So let's put 470 here. Here you are getting 8 mm at 105. Now overall status is revised thickness or AST. That means whatever thickness or steel you are providing, it is not sufficient, because this modification factor is in simply supported, it is 20 actually. So it should be less than 20. So what can we do in this case? Let's increase the thickness to let's say 130. Again, check the status. Still it is not satisfied. Again, increase this 140. Now it is less than 20, so it is saying okay. Now you should change the steel also, don't forget. Because once you increase the thickness, the AST required will be less. So let's make it 390. Again, it is creating problem, because see, modification factor depends on the thickness and steel also. So you reduce the steel, that's why it is again changing this. So what can you do? Either you can increase the steel or you can increase the thickness. So let's increase steel. Let's say 425. Take it out. Still it is not satisfying. So I think it is better to increase the thickness. Because many times if we increase the steel, the client is not happy with that. So little increase in concrete thickness may be suggested. Let's say 150. And again check. So it is saying okay, but you can reduce the steel. Let's try this again. Let's 370. And yes, still it is okay. So even though you can reduce the steel, but thickness required is 150 mm. So this way you can design the one-way slab, control. Once you change the thickness, change the steel, again check the status. And if this is creating problem, either you should increase the thickness or increase the steel. Is it clear to all of you?
Yes, sir.
Okay. Now we'll go to two-way slab. So in two-way slab, we are having 9 conditions actually. So can you see this? These conditions are given in IS 456. Let me check. So in table 26, you get the bending moment coefficients for rectangular panels. That is two-way slab, we can say. Okay. Here you are getting this. So depending upon Ly upon Lx ratios, the coefficients are different. And we get the bending moment at the support, at the mid, depending on whether the end conditions are fixed or simply supported. So there are 9 cases. One is the interior panel, then one short edge continuous, one long edge discontinuous. So all these things are given, and there is a coefficient alpha x and alpha y. Alpha x is for short span moments and alpha y for long span moments. For example, see what is the meaning of these interior panels. I think let's go into the Excel itself. Can you see this? Now let me just zoom this. So we are having a two-way slab like this. For example, so here you can see S4 is a two-way, S3 is a two-way, S1 is a two-way slab. So all these slabs are two-way slabs, but their boundary conditions are different. So here you can see for this S4, this part is discontinuous. This part is continuous. This part is continuous. This part is continuous. Getting this?
Yes, sir.
So this is your discontinuous edge, and that conditions are given here actually. If you see this, now let's say the condition 2 is one short edge continuous. When we say one short edge continuous, that means other 3 edges are discontinuous. So, okay, let's go here itself and tell me which is this condition. For S4, what is the condition? So what I'm saying here, see, this is your discontinuous end. So this is your short span. So one
Outer
short
edge discontinuous.
edge discontinuous. Okay. And these are there is a slab over here, so there is a continuity. So this is continuous because this slab is here. Again, this is continuous, and this lift wall, if you want all of that, still that means one short edge discontinuous is the case. So which is the case in RISE code? One short edge discontinuous. So hai kya kaha? Which one is there?
Serial number 5.
So serial 5 is saying two short edges discontinuous. Actually, in our case, only one short edge is discontinuous.
3 edge wala.
Okay.
3 edge
now
wala. Serial
let's
number 8.
see here.
Serial number 8.
Can you find this case? See, this dark color is the continuous edge, and this the discontinuous. Do you find this anywhere here? Which is the case in our case? So this thick line is continuous and thin line is discontinuous. So what is our case in this? If you see this,
3.
Second.
but 3 there is a long edge actually discontinuous. But our short edge
Second
is
number.
discontinuous.
Second number.
So 2 will be the case. Okay. So what is that? Yes, 2 number. So one short edge. Actually, it should be discontinuous. Huh? Kuch to gadbad hai yahan.
Yes, sir.
Right. Kuch to gadbad. So this is the case here. So even though you look at this picture, you will understand what is the case here. So let's design that slab. S4. So S4, what is the load on S4? Dead load, SIDL, and live load. So SIDL, let's take, yeah. So live load is 2, SIDL is, let's say, 1.5, floor finish only. And self weight. So self weight generally is calculated by the Excel sheet. So let's put all the loads here and span and everything. So span is 3.2 here. By long span is 3. कितना है?
3.12 plus 1.17.
ये है ना हमारे पास. So the span, a longer span. So it will be 3 plus 4.
4.29.
29. Okay.
4.29.
And this is your 3.2 meters. Okay. So let's put the values and everything here. Grade of concrete, let's say M20. Grade of steel Fe500. Cover to the reinforcement 20. Now you can name whatever name is there. It is a S4. Give the name as S4. And the case, select the case here. Panel type, 2 number. Correct. And LX is 3.2 and LY is 4.29. Assume thickness as, let's say, start with 120 mm. Live load is 2. Once you go down, then it is asking what is the finish load, working finish load. So it is our 1.5 in our case, for example. It depends on the thickness of the screed and tile you assume. Actually, last time we forgot that. We only took that. Yeah, yes. We forgot the tile last time. See, floor finish. This load is for screed. Huh? Please keep in mind. So we should add tile weight also. So tile we can take generally 0.01, that is 10 mm thickness.
Into 25.
And let's say 22. So now it will come near about 1.5. So okay, we have taken 8 is fine. So tile plus floor finish, that is screed. So it will be 1.5 in our case here, and outermost reinforcement along short span, same for as one way slab. And let's assume the diameter of this bar is 8 mm for longer and shorter both. Then go down. So this is the AST required, 144. Let's put 150. Provided steel, assume this as 140, 150. So go down. So final strategy is okay. Correct?
सर कंटिन्यूअस और डिसकंटिन्यूअस को थोड़ा एक बार बता देता.
Concept.
यस सर.
तो concept ऐसे है. See, it is similar to beams. You can see here this S4 is there and S3 is here. So if you, the loading diagram will be look like how the loading diagram will look like. If I draw a section like this, S4 section. Let me draw here itself. So there is I'm drawing a section over here, a loading diagram section. Here you can understand here and this. So this support is what? B23. Yeah, नीचे निकलोगे confusion हो रहा है क्या? Okay. And we are having a load on this. So this is a S3 load. This one is S4 load. And this one is again S5 load. So this is your S3, this is your S4, this is your S5. And it is a continuous because these supports are nothing but the beams. B25, then this is B23, then this one is B27. So it is a continuous slab, isn't it? Can you understand by looking at this? It is a continuous slab. That means we will get moments like this. Yes or no?
Yes.
So there is a sagging moment, MS, let's say there is a hogging moment, MH. That means I can say this is your fixed condition because there will be negative moment at this point, on this beam. There will be negative moment here. So if you draw the section like this, then you will find this again negative moment here. So this is the concept of continuity. And is there any beam slab over here? No. So there is a discontinuous. So it will be 0 moment. So let me draw section like this also. If you draw the section like this, and if I want to draw a loading diagram there, so कैसे रहेगा ये? ये मेरे beam supports है. I'm drawing vertically here. Please try to understand. And these are the loads. So this is the load for S4. Then this is your B9 beam here. This is the loading diagram of slab. Please understand. Now here you can see as there is no slab over here, this is a discontinuous end. So we will have a bending moment 0 here at this, and then I will have a moment like this. समझ में आया सभी को?
Yes, sir.
And as there is a negative moment, we can consider this as a fixed connection, fixed end. Okay. Again here in S5 case. Now here there is a problem. There is no slab over here actually. So in this case, I may assume this as a discontinuous end. And if you are transferring the slab reinforcement in the shear wall, then you can assume this as a continuous. There is no problem. Getting this concept?
Yes, sir.
Okay. Now let's go into this. Now here, so you got this. So steel is okay here. Final status is okay. Now what is the steel required here now? 8 at 225, 285 along short span at bottom, and 8 at 285 steel at top. So there is two calculation. One is the short span moment calculations. So this is short span calculation. Steel at bottom is 8 at 285. Steel at top is 8 at 285. And here long span moment is also there. So long span steel at bottom is 8 at 260 and steel at top is 8 at 60. अभी ये long span और short span कौन कौन से इसमें? Let's go on our case. So whatever I am discussing this, MH जो बोल रहा हूँ मैं, MH ये मेरा long span का है, short span है, negative moment, support moment.
Short span.
Is this MH for long span, short span? Because this is the short hand direction. So MHS. S for short span, MH for hogging. Okay. Then this MS is for short span or long span? This
Short span.
this span is short. So the
Short
sagging moment for short span. Again, this negative moment is for MH for short span. Okay. So that is the meaning of this. And this sagging moment, tension is at the bottom. So steel at the bottom. Hogging moment, steel at the top. That is support. Here it is saying now. Let's only think of this short span. So short span bottom steel, that is sagging moment. And steel at top means hogging moment. So this steel you will provide at the top along short span. This steel you will provide at the bottom along short span. Now there is one more case. There is a long span. As it is a two-way slab, there are moments in both directions. So long span, steel at bottom. So let's go again to the problem. Now this is your bending moment diagram for this. So this is your MS for short or long, this moment. Long. And there is a
Long.
MH here, which is also for long. So these are the two moments. So for whatever these moments are coming, the steel is calculated for this. And we will provide the steel in this direction. So the direction of long span steel is like this. This is your long span steel at the bottom, which I am designing for this vertical steel you can see at the bottom. So this is my bottom steel. Now there is MHL. So I need to put the steel on the beam B9 also, over the support. Over the support, I will put the steel like this. Okay. So this will be your over the support, correct? Which is taken, which is for this bending moment. All of you getting this?
Yes, sir.
And for shorter span, let's say this is your bottom steel, which is for this moment. And there is a negative moment also along the shorter span. So I will provide negative moments, steel like this. I'm just drawing it dotted over the support. Detailing we have already seen yesterday. And again here I will provide the negative support steel here, 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 here. And as there is no moment at this point, I can ignore the steel here. But generally we provide minimum steel, as I told you yesterday, to avoid the cracks. So minimum AST I can provide in this direction also, over the support. Over the support means top steel. So if you look at the section of the continuous slab, so again, let me fresh drawing nickel zone. So if I draw the section along the shorter span of the slab, it should look like this. Our case is S4 here. This is our because this end is also continuous, this end is also continuous. That is fixed. So we will provide the steel here. Along short span is this. This steel along short span, and this steel is along short span but at the top. Again here, along short span at the top. And this span is short span. So this section is nothing but this section, whatever I drawn here. Now along this longer span, this section, this loading diagram you can see. Let's draw the actual say how does it look like? It is a two. Now in this case, this is your longer span, long span. One end is discontinuous. So this is your discontinuous end because there is no slab to the left side. And this is also your S4 only. Don't forget this. Now here what we are getting, ideally, there will be only bottom steel over here. And as there is a continuity over here, we will provide. So this is your top steel along long span. This is your top steel along long span. This is your bottom steel along long span. And there is ideally no requirement of steel because there is no negative moment. Okay. But as I told you yesterday, for durability purpose, generally we provide minimum steel. So you can provide here minimum steel. No problem. Okay. So this is the detailing of 2S slab. And you can design this like this. So you can assume any boundary conditions and put the steel accordingly. So in our build case, what are the cases? Just let's rephrase the cases here. Now there is a, okay. Now tell me in each ये जो है हमारा problem statement. So what is the, if you consider this as it is a one-way slab, there is no problem, simply support it. S1, tell me which case you'll use. S1, where is the discontinuity and where is the continuity?
Near the toilet beam, there is a discontinuity.
There is a discontinuity, but you can see the slab. So why it is a discontinuous?
Sunken slab.
It is a sunken slab. Yes. So this is very important criteria. Whenever I say continuous, the slab should be in one line. Huh? There should not be any difference in the levels. Top level of the slab should match. So here you can see here, in this case, if you draw the section like this, which is passing through S1 and S2. So S2 is sunken slab. So you can see here, so your S2 is like this. And your S, क्या है वो नाम उसका? S1. So as there is a sunken portion, can you consider this as a continuous slab? This part? No?
No, sir.
So that's why there is a discontinuous. So this part is discontinuous. This part is discontinuous. Then this is also discontinuous. This left, there is no slab on this side. Is there any slab on the right side here?
Yes, sir.
Yes, we have
Yes,
the
sir.
slab. So let me assume this as a. So this is. This is my continuous. Is it continuous over here, over the beam this side?
Continuous.
Yes, sir. Continuous.
No, actually, because this is also sunken slab because it is a balcony.
Oh, yes, sir.
So 150 down it is there. So it is also not continuous. So we'll. So this is also D. D. Here also it is a D. Only continuous at this point. Green line. And this is span is it longer span or shorter span? So ये मेरा 3.12 है and shorter
Longer.
span is 2. So longer edge continuous. I generally prefer, instead of going into the IS code, see, to understand the language you may get confusion, maybe better to just refer this. अभी क्या था हमारा one long edge continuous है ना, मतलब one long edge thick चाहिए ऐसा सिर्फ, बाकी तीनों discontinuous. Where is the case? Long is
7.
only, yes, long is only, so 7 will be my case. So in this we are having a 7 case. So I'll use the 7th case over here. For S4 we have used 2 na, I think 2 लिया था ना. Now for
Yes, sir.
S3 क्या होगा बताओ?
One shorter is discontinuous. One
So
shorter is discontinuous.
this is also continuous because ये S4 में continuous था, मतलब S3 में है ही ना. That's why we have taken that. So this is my continuous. Is this continuous?
Yes, sir.
Horizontal one?
Yes, sir.
Yes, it is also continuous. Is this continuous?
No, sir.
No, sir.
No, because there is sunken slab, so it is a discontinuous. Now here also it is continuous in this zone, green zone, but here actually there is a discontinuity. Okay. Now in this
Yes,
case
sir.
you can assume, if you feel that within this zone I am not getting continuity, why not to assume this total portion as a discontinuous. So this can be also a choice. See, assuming discontinuous is very easy and acceptable. Assuming continuity, you should be 100% sure that it is continuous. So in this case, actually, I'm not sure that within this zone, actually, I cannot continue the steel. So it is a partial continuity, half slab and half is different. So in that case, safer approach is to assume the discontinuous. Okay. Safer approach. Now tell me, one long edge and one short edge continuous. What is the case? Long and short continuous.
Fourth number.
Fourth number, sir.
Fourth number. Now tell me for S5. Here it is continuous. Yes. Here also we are having. Now there is one key point. Whenever I assume continuous or discontinuous, is that, let's say I'm assuming this S4 for the time being. So it is a two-way slab. So I will provide steel in this direction also and in this direction also, correct? So this is my main steel direction. Both are main steel directions. So whenever I assume that this is main steel direction, that means this is my span direction.
Yes, sir.
Here, and also I'm having span in this direction. So this horizontal spanning should be there in this slab also. Okay. For example, what I'm trying to say, I'll let me remove this first. For that, let's say my slab is like this. Assume. Now can I have this continuity for S4? ये हो सकती है क्या continuity?
No, sir.
Yes.
No, sir.
Because my adjacent slab is having span perpendicular, not in the horizontal direction. So this continuity is not possible for this case. Please try to understand. That means there has to be, if this is the case, then here also it should be the case. Either one way or two way, whatever. If this is the case, then also here it has to be like this. Okay. Fine.
Yes, sir.
So this is the important point here to understand. Now again go to this point. Then here also as this now why I was telling. Now here this is my direction. This two-way slab. This direction is there. What is the direction of the staircase slab? This one. That means it holds good. So it is a continuous here. Again here it is a continuous. Is it continuous at B3 level?
No, sir, it is continuous.
At this point, is it continuous? There is no slab, so no continuity. Now here, I don't know the span, so you can assume that whether it is a longer or shorter, and select one of the case.
3, sir.
I don't have measurement. Hey, camera. I don't have the measurement here, so I'm not sure. Okay, looks almost square. Square रहेगा तो क्या होगा? Short और long कैसे करेंगे? Will there be any confusion?
Yes,
Should
sir.
not. Okay, ये तो सिर्फ ये look at the thick lines and then take the decision. Okay. If it is a square. So this way we can consider the cases and get the steel and do the design. So 2A slab is done over. Then you can select the cases and just do the design. Yes.
Sir, corner.
Huh? Hello. Hello.
Sir, torsional reinforcement for two-way slab.
Mhm.
At continuous
Yeah.
edge.
At continuous edge we can provide, but generally क्या होता है, we are having that distribution bars coming actually. So we generally don't consider that, but yes, if you want to consider the torsional reinforcement, it is generally for the simply supported beams. Okay. Design of simply supported 2A slab without provision. And I think there is a case with provision also. So if you want to design the simply supported 2A slab without provision to resist the torsion, then you can use this sheet. Okay, but generally क्या होता है, we are having, see, let's say, as I told you, we generally provide the steel at the core. See, there is a negative steel, means top reinforcement here, let's say. Okay, I am providing, this is top reinforcement I am talking. And again, from this direction, I will have a top reinforcement. So generally this, whatever is there, it takes care actually. So we generally avoid providing additional torsion reinforcement actually. This is taken care most of the times. And that's why I told you, whenever it is a discontinuous, please provide the steel even at the discontinuous edge. Just to take care of the torsion. Okay. Now, if you want to design the staircase slab, staircase slab is generally one-way slab. If you look at this direction of the slab, you can see this. This is a one-way slab. And you can design this as a simply supported one-way slab. So this case you can consider here in this. Now in the working live load, finish load, you should also add the weight of steps. So because there are steps actually. So apart from the waste slab, so this is your waste slab actually. Actual concrete portion is this slab.
Yes, sir.
We call it as a waste slab. And there are weight of the steps also additionally. So we need to add the weight of the steps into that. I think we have shared the design basis report to all of you. Please refer how to calculate the weight of the steps and that.
Yes, sir.
There
Yes.
is a formula
Yes,
for
sir.
that, and you can add the step weight and you put that weight in the finish. This thickness is overall thickness of the waste slab, and whatever additional weight is coming due to the steps, put that additional weight in the finish. So tile weight, screed weight, and steps, weight of the steps here. That is the only difference. Nothing much special for staircase. But the speciality is in the detailing part, which is very important here. So generally, you know that there is a mid-landing beam for the staircase. Why is that? So if you see this, now tell me where is the mid-landing beam for this staircase? Kahan hai? Because
B17.
B17 is the mid-landing beam. Okay, mid-landing beam. So we are starting from here actually. This is my ground floor, let's say, and I will go to the mid-landing level. Then again, I will go above, and this will be again first floor level. So this is a mid-landing beam. So we are having two flights actually, this one and this one. And as it is a slanting, slab is slanting, we need to put the reinforcement like this. So this is the standard detail actually, nothing special in this. Your main steel is this. This one is your main steel. Now you please try to understand your longer span is the main span in staircase. I hope you know this. Even though it is a one-way slab, it is not along the shorter span. Yes or no? Is it like this? Generally, we say that if Ly by Lx is less than less than 2, then it is a two-way, and it is greater than 2, one-way. And we provide the main steel along the shorter span. So is it the case?
No,
Yes,
sir.
okay. It will not possible. It is
No.
not possible because the level is not same.
Not
And even
continuous.
this beam is also not available to receive the steel from the staircase. So this is your, even though it is a longer span, this is your spanning direction. So whenever you put the span in the one-way slab design, put the longer span. Okay. You will consider this span as a design span for staircase design. That means you will have this steel is a main steel, right? This is your main steel, and whatever dots are there, these dots are distribution steel, correct? And this sloping steel is a main steel.
Yes,
So
sir.
even though the sheet is saying here, please try to understand. So therefore I generally say don't look at the words always, means please understand the meaning. And then, so now what I will do here, will I consider long span or short span? Outermost reinforcement along short span or long span? Will it be short or long?
Long.
It
Long
will be
span.
long only because I want main steel, and this sheet doesn't understand is it is staircase or what. Okay, so that's why it doesn't understand. It will be short only here in this case also. So don't look at that number. And even though it is saying short span steel at bottom, it will be that long span. Please try to understand. And this long span will be distribution steel. So keep in mind the words are not important in this case. The calculations and meaning behind is important. You should know what this sheet is doing the calculation behind the this screen. Now you'll see here there are small detailing part is always important, that this main steel is there which is going like this, and this horizontal steel is going like this. So there is a crossing over here, crossing of steel. This is to avoid the cracks which will happen over here. There is a possibility of cracks over here if you don't cross the steel like this. Okay, because as this will try to bend like this horizontal line and this horizontal line, there is a tension actually in this. So there is a tension in this direction, there is a tension in this direction, correct? So this will try to open up, and while trying to open up, there will be crack, and to avoid this crack, we are crossing this reinforcement like this. Okay, this is a critical detailing in staircases. Similarly here, this will go like this, and this will go like this. So there is a crossing over here. All other details, please refer this sketch. And this is for one flight, and for this other flight also it will be same. Generally we start from the plinth beam. Then if we are starting the staircase from plinth beam, then this will be the detail. And for all other staircase details, it will be like this in the upper floors. So we are done with the, I think, slab and everything. Any questions? Yes. Avinash,
Yes, sir.
question?
सर वो अगर इन केस स्टेयर में क्रॉस सेक्शन हो जाता है, ये बार वहाँ होना चाहिए कि नहीं?
क्या क्या क्या?
ये अभी स्टेयर वाला आप बताए ना, वहाँ सेक्शन क्रॉस कर रहा है, वो क्रॉस करना चाहिए या नहीं?
करना चाहिए ना, ये this should be as it is. अभी whatever you can see here, here you see this, the detail should be like this only. On site also, please keep it in mind. You may give the correct drawings, but the site people are many times, if the people are not experienced, they create mistake at this zone. So you should check this, correct? So the crossing is required.
ओके सर।
या
मैंने यहाँ नहीं देखा था, सो वो इसीलिए मैं पूछा था इसको।
नहीं नहीं, this is a must actually. This is a common mistake actually. The people directly put the steel. समझो ऐसे है आपका, which is very very wrong method. समझो ये आपका waste है slab. So it may happen that you will directly do like this. Okay.
Yes, sir.
It may happen like this. And here also, I don't know whether you will put still like this or something. This is wrong detailing. This is wrong detailing. There will be crack over here. Correct.
Okay, sir.
This is a common mistake generally for the beginners. Either the beginner is a contractor or beginner is a structural engineer. They will do the mistakes over here. So even when there is a change in angle, okay, you must think of the crossing. Changing angle means even though it is a 90 angle, we also do that way. Okay. So 90 degree ka kaun sa hoga? Okay. Let me give you some detail. So you might have seen chhajjas coming out of the beam. So there are chhajjas in the building above the windows. So let's say this is my beam. Generally chhajja we get at the bottom of the beam. This is your chhajja, let's say. And above that there is a brickwork, you know this.
Yes, sir.
So there is a brickwork above this beam, and this is your lintel level. This level is lintel level. So we are having what? There is a window here. We have a window like this, window with glass and water. This is not structural member. Structural member is only this RCC beam. And this is RCC slab or chhajja or cantilever slab. RCC cantilever slab. In this case also, I cannot provide the steel like this. Please keep in mind. You may say that I will provide the steel like this only, as it is a cantilever. No. Generally, the crossing is required. Generally, we provide the crossings in this fashion. So there will be steel like this. Single bar only. Then this. Then this. Here you can see the crossing. Okay.
Yes.
So the bar is in one piece. Please keep in mind. That means the bar is like this. One piece only. There is no cut bar. Huh? This total bar is one piece. And this crossing
Yes,
is
sir.
required to avoid the cracks. So when there is a change in the angle between the two members or same member, some beam and slab angle is changing for cantilever slabs, or there is a staircase, or there is some inclined slab or whatever. Please keep in mind, you must provide such kind of crossing. Otherwise, there will be crack here. So these are some standard detailing practices. You'll find it in IS code also, SP 16424. I don't remember that name. So there you'll find all these things. So this is the case. So there are standard and good practices regarding the detailing of reinforcement. You must follow that. Otherwise, there will be problem. Once there is a crack, then the leakage will be there. Once there is a leakage, then it will reinforcement will corrode, and you know that it will have a problem to the durability. So in durability, okay, let me subject aaya to bata do. So in durability, the important point is detailing. So if you do the correct detailing, whenever I say correct, it is appropriate word. I would say it is appropriate. Then lot of problems regarding the durability will be solved. So in durability, first criteria is the detailing, second criteria is the cover to the reinforcement, then painting, plaster like this, plaster, painting. Plaster painting is a non-structural item, but still it is important. Cover is a structural part because we provide the cover to the slab, beam, columns, and so on. Different covers are there. And detailing is also part of the reinforcement. So it is a structural part. So these two parts are in our hand actually. So we should do the correct detailing. And these are the some examples of those detailing. I may be having one PPT. I will share you that study material in study material. Good detailing practices. Okay.
मैंने तो इतना अच्छा काम का ऐसा कहीं डिटेलिंग करके स्ट्रक्चर इंजीनियर भी नहीं देता है यहाँ.
नहीं, फिर ये रॉन्ग प्रैक्टिस है. सभी राम भरोसे चलता है, बट ये इट विल नॉट बी मोर ड्यूरेबल बिल्डिंग.
एक जनरल क्वेश्चन है. हम लोग ग्राउंड से फर्स्ट फ्लोर तक बीम ले जाते हैं कंटिन्यूअसली, लेकिन ऊपर जाके वो बीम वहाँ फर्स्ट फ्लोर पे स्टॉप हो जाता है. तब उस केस में जो सरिया रहता है,
कॉलम बोल रहे हैं क्या, बीम बोल रहे हैं?
हाँ, सॉरी कॉलम.
हाँ, हाँ.
कॉलम हम लोग ग्राउंड से फर्स्ट फ्लोर तक ले जाते हैं, तो वहाँ वो स्टॉप कर देते हैं. लेकिन उस केस में सरिया वो क्या करते हैं कि वो वहाँ बेंट होता है कि वो सरिया कट हो जाएगा सर.
हाँ, ओके, अच्छा क्वेश्चन है. ओके, सब ये ना, let's say this is your column.
Yes.
Column, generally for the column there is a beam always. General
Yes.
case में तो रहता ही है. Let's say this is your terrace. ये terrace है, मतलब this column will not go above. This is your terrace level.
Yes sir.
And let's say you are having this is your saying plain beam समझो, ground floor ये समझो, ये आपका plain beam है. Then you are having footing over here somewhere, maybe below the ground. ये आपका beam है, plain beam. Okay, so this is your building. Now you're asking what to do regarding the column. Say, if you are assuming this beam as a fixed end beam, generally whenever the beam is resting on the column, we assume it as a fixed beam. Yes or no? And in that case, we have a bending moment in that case, like this. This is your bending moment, and you provide main steel over here for the beams. Okay, let me remove this. That means I will provide the main steel here. ये मेरा main steel रहेगा, correct? Okay, and then I will develop this. If you are developing this beam steel into the column, then if you are considering this column steel, अभी यहाँ से नीचे से आने वाला है वो, यहाँ से ड्रॉ करता हूँ मैं, मतलब वो सही समझ में आएगा. Now you will have, ये ऐसे आगे जाने वाला है. If you are this blue color developing this here in the, that means this blue steel, whatever which is in the beam, as there is a development length, you have already considered here. That means this moment is also considered here by this blue bar. In that case, even though you don't do like this, doesn't matter. Okay?
Yes, sir.
Because that steel is already provided from the beam into the column. So in that case, even though you cut this at this location, should not be any problem. But if there is no fixity assumed, so there is no question of the steel itself. So getting this, so I would suggest you, if you cut this, okay. But from practical point of view, what I generally recommend, bend this. Okay.
Okay, sir.
General recommendations. Now, why I'm saying this? Any guess?
तो वहाँ एक्स्ट्रा बार देने की जरूरत नहीं है, डेवलपिंग बार देने की जरूरत
नहीं, वो देता है, मैंने ये भी दिया और ये भी दिया. चलो समझो. सी, समझो क्लाइंट को लगा कि मुझे अभी एक्सटेंशन करना है आगे.
यस सर.
So in that case, I can break this and I will bend these bars and ऐसे आगे आएंगे, and then I will lap the bars above. So that is one case. There is a possibility for extension in future. I can break this and I will take out these column bars and make it straight and lap them. Or there is another way to do this. Generally, we extend the column bars into the terrace. ऐसे.
Yes,
okay.
sir.
ऐसे लेते हैं, and this length is lap length, which is 50D. This length is lap length.
Yes sir, ये वाला देखा है सर.
So ये है, बाद में इसको कंक्रीट, ये पुअर कंक्रीट से करते हैं, मतलब ये we don't do rich concrete here, नहीं तो ब्रेकिंग के लिए बाद में फ्यूचर में डिफिकल्ट जाता है. So I will do the concreting here block, but with we can say, क्या बोलते हैं, low grade concrete, we can say 5 grade M10 M5 समझो, नहीं क्या, so that I can break it in future whenever I want the extension. So this is the general practice. It should be the practice, I think. अभी if I have not considered the provision in the column in designing, समझो मैंने ऊपर वाला extension का load ही नहीं लिया है. Getting? Say I have not designed this column for the further extension. In that case, don't allow this to the client. नहीं तो फिर वो बाद में extend करेगा और आपने डिजाइन ही नहीं किया इसको. So उनको पहले ये बार कट ही कर डाल दो इधर, समझ में आया? So that even though he is having in his mind कि यार मुझे करना है extension, तो थोड़ा सा difficulty जाएगी उसको आसान नहीं बनाने के, क्योंकि वो they may do like that without asking you also. So उनको पहले से ही वो ये करो, मतलब option cancel कर दो उसको. So in that case you can either bend or cut, whatever.
सर तो इसका इफेक्ट कुछ पड़ेगा कि नहीं अगर कट कर देते तो?
नहीं, किसके लिए? ऑलरेडी ये मेरा ब्लू बार है ना मोमेंट लेने के लिए, तो फिर इसके कुछ नहीं प्रॉब्लम आएगा.
ओके सर.
एक्सक्यूज मी सर.
यस
सर, एक पूछना था, कॉलम स्टार्टर क्या होता है?
कॉलम स्टार्टर, ओके. अभी ये प्रैक्टिस नहीं है, Generally, we are avoiding the column starters because of the
यस सर, वो
earthquake
साइड
part.
अभी तक देखा नहीं है मैंने।
कॉलम
लेकिन
स्टार्टर मतलब क्या करते हैं? विडो ओके दिखाता हूँ। Now, how we do the concrete here actually? Whenever we start the concreting of footing. So concreting कैसे होगा इसका? क्या होगा?
Using shutterings.
So we will do the concreting here. Yeah, this reinforcement is already placed. Please keep in mind. एक काम करता हूँ मैं, footing का भी reinforcement निकालता हूँ. Side पे कैसे करते? Okay, so this is your reinforcement. Main and other side is reinforcement for footing. Then I am putting the column reinforcement also along with the stirrups. Yeah. So this is already there. Now I will provide a side over here, shuttering here. I will provide the shuttering in this side wise. I will provide the shuttering here, and I will pour the concrete, and I will do the concreting here, right? So today, let's say I have done the concreting over here. Fine. Now this concreting is done today. Now I need to do the concreting of column tomorrow, but generally the people don't do the concreting tomorrow. They will do the starter. Okay. So they will align this reinforcement because the column height is generally 3 meters or more in general. So this cage is not in place. So what they do put concreting only within this zone. This portion only. To the next day, they will do the vertical alignment of the reinforcement correctly by providing some supports like this.
Yes,
and they will create this base, and they will do the concreting only within this zone to the next day. Part of the column. This is a column dimension. This is a part of the column. To make it this keep in vertical position and to give him the base. Once you do this, so this will be a smaller side actually in this case. This side will be smaller, and then again to the next day he will put shuttering or formwork here. So this is my ply. Please try to understand. This is not concrete. So this is my ply to the next day after the starter is done, and then I will pour the concrete to the next day. So there is a 3-stage concreting here. First is the footing, second is the starter, right? So I will do the concreting of footing first, let's say today. To the next day, I will do the starter concreting, and to the third day, I will do the actual column concreting. But this method is nowadays not recommended by structural engineers because what happens, there is a cold joint. To the next day, as I am doing this concreting, there will be cold joint, yes or no?
yes, sir.
Construction joint or cold joint is there. And this cold joint, whenever there is an earthquake, there is a horizontal shear, all of you know. There is a horizontal shear, and at this cold joint, we have already created a weak joint. So I have created a situation where in earthquake this will crack. Okay,
Okay,
because
sir.
it is a weak zone, and in earthquake column and beam joint or column and footing joint, they are very much important because there are major shear forces and major moments at the joints. If you consider this part here, let's say here. So if you do the starter here, then there will be, let's say there is a starter here. Let's say there is a starter here. So you are creating cold joint and you know that there are heavy moments in the earthquake. जब हम बेंडिंग मोमेंट निकालते हैं तो बीम का बेंडिंग मोमेंट कैसे रहेगा? ये ऐसे रहेगा. So this is a huge bending moment over here. Again, there will be more shear force also. And the column में भी ऐसे bending moment रहेंगे बड़े-बड़े. And there is a huge shear force. So at this zone, there is a huge shear force and huge moments due to the earthquake. And we are creating a cold joint or construction joint there or weak plane. So we are telling him to fail here. So this is very not expected. That's why column starter is not recommended. Okay. I know that if you don't do the column starter, it becomes little difficult to do the say the column work, form work and concreting work, but it's okay. Difficulty of the contractor is not our part. We should do the correct detailing and we can say technically correct. Got this?
Yes,
Yes.
sir.
Okay. Any questions?
No, sir.
Okay. So we will conclude today's session then.
Okay, sir.
So thank you all.
Good night, sir.
Thank
Thank you,
sir.
sir.
Thank you, sir.
Thank you and good night to all.
Thank you.
Good night, sir.
Good night, sir.
Good night.